Okay, so this is the third video for activity 2.2, and now we are in page 181 of our book, and we are talking about fractional exponents. We're going to talk about in this video about two different types of fractional exponents. So I'm going to start with the first one. The first one is what happens when I have something in the form, let's say 2 to the 1/2 or 4 to the 1/2. Okay, so if we go into your calculators, and I would like you to go into your calculators, and you go to home mode, okay, in other words, in calculator mode, and you do 4 to the 1/2, that is this particular algebraic expression we have right here, right? 4 to the 1/2. Don't forget, please don't forget to put the parentheses, okay? So your calculator understands what it is that you want. If you do 4 to the 1/2, you're going to get a 2, okay? If you don't get a 2, it's probably because you're not putting the parentheses around here. Okay, now if you do 25 to the 1/2, okay, which is 25 to the 1/2, you will get a 5. So why don't you try this in your calculator and see what you get. Okay, so we can see that this number right here is the square root of 4, right? And this number right here is the square root of 25. So basically, what I'm saying is that 4 to the 1/2 is the same thing as the square root of 4. And I'm saying right here that 25 to the 1/2 is the same thing as the square root of 25. Okay? Now that's very important to know. We're going to go back to this. Now again, you want to go in your calculator, and I want you to do a to the 1/3. Right? Again, make sure you put this in parentheses, right? And if you do a to the 1/3, you are going to get a 2, which is the cubic root, the cube root of a. Yes? So a to the 1/3 is the cubic root of a. Okay, so this is really getting very interesting. If I do, let's say, 64 to the 1/3, yes, you know you're going to get a 4. Okay, and that means that is the same thing as the cubic root of 64. So that means that the cubic root of 64 is the same thing as 4 to the 1/3. Okay, we're good. Okay, so now what is it that I'm finding? I mean, what is it that I'm finding? I'm finding that if I want to find the nth root of a, all I have to do is take your a, which is the number under the radical, and set it as an exponent. Okay? The power is the power, the numerator of the fraction, okay, is the power that a has, which is 1, and the denominator of this fraction is this number right here. This number right here is the index or the root, okay? So it will be a to the 1 divided by n. Okay? All right, why don't we do problems in page 182. Page 182. Again, I'm going to do the evens. You're going to do the adds. Okay? Actually, let me just do the adds and you do the evens. Forgot what the arrangement was. And then you check in the back of the book. Okay, so let's start with problem number 25. The first add problem. We have 100 to the 1/2 let me just represent it as a radical. Okay, so this number right here will be this number represented by the denominator of the fraction. It's a 2, so I don't have to write it. Okay, actually what I'm going to do is, so you can see it, I'm going to put the 2 here. Yes, so this 2 is red, is going to go here, right? And this 1 that is green is going to be the exponent of my base, and the exponent of my base is going to be 100. So really what I have is, remember, I don't need to write this, so that will be the square root of 100 to the 1, which is 100, and that's equals to 10. Okay? So all we did is to write it in radical form. That's what really they're asking you to do. Okay, let's do number 27. Okay, I have 27 to the negative 1/3. Okay, so this problem is a little more difficult because it has the negative sign. But no panic. All I need to do is move it to the denominator, right? Move it. Move it. Move it to the denominator. Anytime we have a negative exponent, we need to know that we need to move it, to move the number. So if the number is in the numerator, it's going to go to the denominator. If the number is in the denominator, it's going to go to the numerator. So I'm going to move it to the denominator. Okay? Now I'm going to go here, and now I'm going to write this as a radical. Okay? This number right here is the denominator of the fraction, right? This number right here is what we call the radicand, the number under the radical. Yes, and this number right here is the numerator of the fraction. Okay, so now what I'm going to have is I'm going to convert this to a radical. Yes? Now, this number right here, this 3, is going to go there. Yes? This number 27 is going to go under the radical, so that's going to be 27 to the 1, because the 1 here is going to represent the exponent of the radical, okay? So now what I have is 1 divided by the cube root of 27, and the cube root of 27 we all know is 3. So the answer to this problem is 1/3. Okay? Remember that this negative sign was definite, moving the expression to the denominator. Okay, problem number 29. In number 29, I have negative a to the 1/3. Now, this problem is different. I want you to see the difference between 27 and 29. Here, the base is negative. I don't need to move this expression anywhere. All I need to do is rewrite this expression in a form so you can understand in a radical form. Okay? So what I'm going to do is I'm going to write a radical, right? The radical. And this number right here is going to be in the, it's going to be the radicand or the number under the radical. The 3, this 3 right here, is going to be my index, okay? And this one right here is going to be my exponent, okay? So really what I have is the cube root of negative a, which we all know, right, is negative 2. Now, remember, don't worry that this is negative, because this number right here is odd. Okay? Now we're going to do problem number 33. And in problem number 33, I have 4 times 16 to the negative 1/2. Okay? So let me put a parenthesis in here. And let's see what we have. First of all, because this is negative, that means I can write the whole expression. I can move it to the denominator, right? And as I move it to the denominator, I change this sign, the sign of the exponent. Okay, so I have now 4. I'm going to write this as a radical. Okay, that way I won't have any problem finding the value of 16 to the 1/2. Okay, so I'm going to write a radical, and the index is going to go right here. I don't have to write it because it's 2. This number right here, 16, is going to be written in here. And this number 1 is going to be going right here. Okay, so I really have 4 divided by the square root of 16. The square root of 16 we all know is 4. So 4 divided by 4 is 1. Okay, so what I would like to do now is to talk to you about other types of fractional exponents. In other words, I want to talk to you about an exponent on the form a to the m divided by n. Okay, so let's talk about, yes, an exponent. I'm going to give you as an example 4 to the 3/2. Okay, so what is 4 to the 3/2? Well, you know, I can write 3/2, right, as the combination or the multiplication of two numbers. Let's say I can write it as 1/2 times 3. I hope you agree. Remember that when I have 1/2 times 3 divided by 1, I write the numerators and numerators, right? And the denominators and denominators, right? And what I get is 3/2, right? So 3/2 can be written as 1/2 times 3 over 1, which is 3. Okay, so let me just write it like that so you can see. 4 to the 3/2 is the same thing as 4 to the 1/2 times 3, right? Which is the same thing as, you remember this property, 4 to the 1/2 to the third power. Why? Because you know, if we have 2 to the third to the second, we multiply these exponents and we get 2 to the 6th. So if I have, right, 2 to the 6th, I can say, oh, well, 2 to the 6th is 2 times 2 to the third. I can write it, right? Yes, because I get a 6 like this if I multiply 2 times 3. Okay? Well, I know what 4 to the 1/2 is. 4 to the 1/2 is the square root of 4. And this is to the third power. Yes? And I know that square root of 4 is equals to 2. Yes? So the square, to evaluate 4 to the 3/2, so let me just see what we got. 4 to the 3/2 is equals to 2 to the third. Okay, which is equals to 8. All right. So so what does that mean? 4 to the 3/2. I want you to see where we stop before we go to the 8. 4 to the 3/2 can be written as the square root of 4 to the third. Okay. So this number right here, yes, which is my m right here, right? My m. And this number right here, which is my n, right, are represented. This is my m, and this number right here is my n. Okay? So what I'm saying is that when we have a to the m divided by n, really what we're talking about is the nth root, looking here, the nth root of a to the m. Okay? This looks like it's something very intuitive, which you really understand what we're talking about here. Why don't we go to page 184? Page 184, and we're going to do the problems again. I'm going to do the odd numbers, and you're going to do the even numbers, and you're going to check in the back of the book. Okay, so let's start with problem number 35. So I have negative a to the 2/3. Okay? So what I'm going to do is I'm going to try to rewrite this as a radical. Okay? Again, remember that this number at the bottom, yes, is going to be my root. Just like the plant. The number at the bottom, the staff at the bottom is the root of the plant. Yes, the staff at the top is the power. Right? If you are at the top, you have power. Okay, so what does that mean? This is, let me write a radical. Okay, and what I would like to do is I'm going to do it in black so you can see it, right? So we have the radical, and this number right here is going to go right under the radical. So we need to choose two things, this number here and the power there, okay? So the root is what is in the bottom of the fraction. So this is the third, right? The third root of this number right here is the power. So I got to put a parenthesis in here so I can understand what we're talking about. So really what we're talking about is the cube root of negative a to the second. Okay? And what that is, if we are talking about negative a to the second, negative a to the second is 64, right? Positive 64, and the cube root of 64 is 4. Okay, so we're doing really well in here. Okay, so what about doing 125 to the 2/3, which is problem number 37? 125 to the 2/3. Okay, sometimes, it's easy to do a problem one way or the other. Okay, so what is this? This is, I'm going to write it as a root, right? It's the cubic root, right, of 125 to the second power. Okay, remember, this is the root, yes, and this number right here is my power. Okay, now one thing that is sometimes is easy is if I go and I take the power and I get it out. What do you mean? Well, I mean to say that if I have the cubic root of a to the 5th, that's a to the 5/3, yes, and I can write also this root as the cubic root of a all the way to the 5th power. All the way to the 5th power. Let me just, I cannot put the 5 in here. Okay, let me just put it in here so you can see again. If I have the n root of a to the m, I can write this as the nth root of a everything to the m. Okay? In other words, I can have the m inside or I can have the m outside. So if I'm doing this problem without a calculator, it would really be beneficial to me to do this, the cubic root of 125 to the second power. Why is that? Well, I know what the cubic root of 125 is, right? So 5 to the 3rd is 5 times 5 times 5, right? Which is 25 times 5, right? Is 125. So the cubic root of 125 is 5. So this could be 5, right? Set to the second power, which is 25. Okay, so here I did a trick. Let me recap the trick. I have the cube root of 125 to the second power, and because I know what the cube root of 125 is, and I'm going to spend a long time multiplying 125 times 125 to get 25 to the second power, I can get this exponent outside the radical. Okay? And that's much easier for me to work with. Okay, why don't we do problem number 39? And in problem number 39, I'm doing 81 to the 3/4. I had a hunch that this problem is pretty much like the problem we did before. Okay, this is the 4th root of 81 to the 3rd. Or 81 to the third is such a huge number. So what about if we go 4th root of 81 and then we take that to the third power? In other words, we get this power outside the radical. Yes? So what we have is the 4th root of 81 is easy to see. The 4th root of 81 is 3. Yeah, this whole number is 3. And that would be 3 to the third, and 3 to the third is 27. Okay? Let's do now problem number 41. And number 41, I have 4 to the negative 3 half. Let's remember what we know about exponents. When we have a negative exponent, that means that we're going to move it to the denominator, the whole thing, okay? 4 to the 3 half. And now I'm going to go and represent it as a radical. This number is 4 to the third, and then I have a square root. This number right here goes in the index or the root. Okay? Again, I'm going to do my trick. I'm going to get the 3 out, right? And then that will be square root of 4. I know that that number is 2. So the answer here is 2 to the third, and 2 to the third is 8. So that is the final answer for problem number 41. Let's do number 43. Remember that as I'm doing these problems, I want you to take these problems and to do them in, to do the even numbers and to check the answers in the back. Okay? So let's do number 43. We have in 43 negative 32 to the 3/5. So you may be worried about this negative, but remember that you always have to check the radical. So don't panic until you don't write this into radical form. Okay, so I have a radical because I have a fractional, and this number goes under the radical. Yes? This number right here, the 5, goes in here, is the root, right? The number under is the root, okay? The number at the top is the power. I'm going to do the same deal. I know what the 5th root of negative 32 is. Yes? I'm not going to spend all this time figuring out negative 32 to the third power. So the 5th root of negative 32 is negative 2. Why? Because negative 2 to the 5th is negative 32. So this is negative 2, and we're sending this to the third power, and negative 2 to the third power is negative 8, which is my final answer in here. Okay? Okay, let's do problem number 45. Number 45. And in problem number 45, I have x to the 3/4. Okay, easy, a radical. This number is below, is under, that's the root. I have 4th root of x to the third. Okay, now we have problem number 47. We have t to the negative 2/5. Okay, remember that when you have a negative exponent, you need to make sure that you move your exponent to the denominator if the number is in the numerator, or to the numerator if the number is in the denominator. Okay, so now I'm going to have 1 divided by 2 to the 2/5. And this would be what? It would be 1 divided by the root, right? The number below is the root. The number at the top is the power. So it's t to the second. Okay? So number 49. Don't forget to do the even numbers. 49, I have 3x to the 1/2. Okay? Please note that the power to the of 1/2 just affects the base of x. Okay? So I'm going to leave my x here, and this x to the 1/2 is going to be converted to a radical. This 2 is the index, so I don't need to write it. And this x is x to the 1. So it's 3 square root of x, and that's the answer here. Okay, number 51. I have the cubic root of x to the second. This is really easy. Remember, we are converting now from radicals into exponential form. So I have x, and then I have a radical. This number, the root goes at the bottom, and this number right here goes at the top. Okay? So that is the answer for question number 51. Okay, let's do number 53. Remember that problems 51 to 58, you need to write these in fractional exponents. Okay, so we have square root of AB to the fifth. Okay, well, this is easy. This is the number under the radical, okay, and part of the exponential, and it's going to be to a fraction. The number at the bottom is this one right here, which is invisible, is a 2. The number at the top is the 5. And the number in parentheses is just AB. Okay? Okay, so let's go with number 55. In number 55, I have 1 divided by the fourth root of x to the fifth. Yes? And now what I'm going to do is going to take my 1, right? And that's going to be is x to an exponent, and it's going to be x to the 4 is the radical, or the root is going to go below, and the 5, the power, is going to go at the top. Okay? I can also write it as x to the negative 5/4, right? Because this number is in the denominator. Okay, we have one last problem, which is problem number 57. Okay, and in 57 I have a divided by the square root of x to the third. So that would be a, and then I have to write this as a fractional exponent. It will be x and then a fraction. This number is a 2 and this number is a 3. I could write this, I can move this to the numerator, write this exponent, this whole expression, and it will be 8x to the negative 3/2, right? Because I'm moving it from the bottom to the top. Okay? So we finish. We are in page 185. We have one more section to go in activity 2.2. And so you can do the lab and the homework corresponding to the activity. Okay? Thank you.